Well, it seems that this problem has inspired some good debate. That's cool. Let's take a look at it. So all this stuff is just window dressing. The mean standard deviation is 8. Here's the question. What percent waited at least 34 minutes? Now you have to just, I just look at the graph and what part does, at least means what's bigger than 34. That's all of these sections. Now there's a couple ways you can add those percents up. You might say 68% plus 13.5 plus 2.4, which I think would give you 83.9. Another way you could figure out that percent is you could say you've got half of the chart, which is 50%, and then you also have a 34% section over here. So that would give you 84%. Both ways are correct. Both ways are going to round to give you D. Okay. If you can't figure out what waited at least 34 minutes means, then it had nothing to do with the question being weird. Look, this means at least. It's counterintuitive, but that's how it works. All you have to do is do some examples in your head. I do this all the time to double check. It says at least 34 minutes, so 40. Is that at least 34? Yeah. So I should color in this section. What about this section? 46. Is that at least 34 minutes? Yep. 52. That's at least 34. Yep. Just do some trials in your head. Okay? Don't get so caught up in, I don't know what this means, because then you start panicking. Just do some tests. Okay? Number 2. Talia.
Oh, I'm sorry. Okay, so you're gonna have to rewrite these phrases. 12 extra to the third power.
Okay, let's just fix this stuff.
Okay, plus 40 minus 7 and minus 2.
Good. Leave this one, change the sign, and do the opposites. Leave, change, opposite. Okay, so just tell me what you combined and what you got.
12x3 minus 5x squared plus 7x plus 7. Minus 5x squared plus 7x plus 7.
A lot of y'all are still struggling with this. Why? Some of you don't notice that this first term and that first term, they don't go together. They are not like terms because their exponents are not the same. Okay, so you can only combine like terms. So be very, very careful. Yeah, Terrence. Leave, change, opposite. So leave the first polynomial exactly like it is. Change the subtraction to addition. And when you do that, it's like you're distributing the negative, so you got to take the opposite of everything in the second term, second expression. So correct answer was D. Good, Talia. Questions on 1 or 2? Never trying to trick you, just trying to make you think. Take your warm-up, set aside, look at today's notes. In 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. We're doing 3 different things today, but what we're working on is possible outcomes. This is a probability concept. Okay, so we're looking at possible outcomes. There's 3 different options we're going to have. We're going to have multiple groups. We're going to have permutations. And we're going to have combinations. And the big question that I want you to train you to ask yourself is this: does the does the spelling matter? Yes. Does the position matter? Does the position matter? This is one of those days where I need you to set aside how smart you are. We all know that this is an honors class. I look at you, I see how smart you are. I acknowledge it. You're a smart kid. If I didn't think you were smart, I would have kicked you out of the class. Okay? So set aside all this I'm smart stuff and conform your thinking to what I'm going to tell you. Okay, let's see how you do with that. Number 1, your Spanish teacher picks 5 students at random to do a special project. There are 24 students in the class. How many groups are possible? The key to this: does the position matter? Here's the key. There's a group, okay? I'm going to make it a group of 3 to make it easier for you. So we're in our class. I'm going to put you into groups. Here's a group of 3. Cortavius, Delarante, Janisha. Here's another group of 3. Janisha, Delarante, Cortavius. I didn't assign them any special job. Are the groups different? No, it's the same group. Does the position matter? No. If the position does not matter, we call it a combination. Okay? If the position does not matter, we call it a combination. And here's what you will do. You will say N combination R. And here's what we have to decide. N represents the total number in the group. R represents the number that you are selecting. N is the total, R is the selection. So in this case, the total number in the class is 24. Put 24 comma. How many people are in each group? 5. It's a combination because the position does not matter. Take your calculator. Okay, you can already see it all. Type in NCR, parentheses. Just like we did RREF parentheses, you got to remember the parentheses. NCR parentheses, 24 comma 6.
5.
Thank you. Up, enter, switch it to 5. Ooh, made a big difference. Keep going. Make sure you're up. How many different groups of 5 could this class have? It could have 42,504. Probably more than you expected. You know, here's why it's such a big number. Think about it. Once again, I'm going to go to my small group of 3. I could say Cortavius, Delarante, Janisha, but then I could say Cortavius, Delarante, Chet. Then I could say Cortavius, Delarante, Kevon. Cortavius, Delarante, but then I could go Cortavius, Janisha, Cachet. Cortavius, Janisha, Kevon. Cortavius, Janisha, Jarmis. Wow. And then I could start, and then I could, that's how you get 42,000. Wow, wow, wow. Wow. Woke him up. Ask yourself, does the position matter? Look at number 2. In how many ways can you create a 4-digit PIN from 10 digits? You turn on your cell phone. You have to put in your little key code, 4 digits, 8374. If you switch to 8 and the 4, does your phone unlock? No. In this case, does position matter? Yes. So you're going to say NP. Notice how easy that is. Position means permutation. If position matters, then it's a permutation. NPR, parentheses. Can you figure out what to put in? 10 comma 4. Here's a clue. The big number always comes first. Type it in. That's a P. $5,040. Questions? So far, so good. Let's do a couple more. Like I said, you need to conform your thinking to what I say about the position mattering. Getting into a debate about whether the position matters is pointless. You might think, the position might matter. No. Conform your thinking to what I'm telling you. I'm telling you why it matters, why it doesn't matter. So take whatever you might think, set it aside, and adopt what I'm thinking. Look at number 3. You have 22 DVDs to choose from, but only have time to watch 2 of them on Saturday. How many ways could you choose two DVDs? Combination or permutation? If you thought combination, you thought correctly. It doesn't say anything about these being a trilogy. It doesn't say anything about Batman 1, Batman 2, Batman 3. No. It just says you pick 2 DVDs.
If it did, it'd be a permutation.
If it said you're watching the 3 episodes of, what's your favorite TV show? Scandal. You're watching 3 episodes of Scandal in a row. And you want to start, you have 37 episodes, then you might have to say, if it says in a row, it's almost always going to be a permutation. Okay, that's kind of a dead giveaway. All right, so you're already done with this. NCR. Big number always goes first. What'd you get? Wow, small. Is that right? Yeah, that is right, because it's only 2 at a time. All right, we'll do one more together, and then we'll go down to where it says careful. We'll go down there next. Let's do number 4, and this is probably the hardest one for you to wrap your mind around. How many ways can an organization with 12 students line up in one row for their yearbook photo? So we got people lined up for a picture. You've probably taken a family picture before. Who has a lot of brothers and sisters? How many of you guys in 9 brothers and sisters. Cool. Perfect example. Are they kind of spread out in age? Maybe like one of them's 5 and one of them's like 21 or something? Something like that. So you might have like the shortest, the tallest. Something like that. You know, a photographer wants to say, get a cool picture, so they line you up and everything. Here's my point. You got 12 people lined up. Well, let's go back to our group here. All 4, the first row right here, lined up for a picture. Snap it. And then I switch positions. I switch Cortadius and Janisha. Snap it. Is that a different picture?
No.
Change your thinking. Okay, adopt your thinking now. Since the people are in a different order, that picture is different. The position matters. Okay? Go back to Denisha's example. 9 kids, lined up. Shortest to tallest. Snap. Now say I take the tallest one and I just move them into the middle and switch the other one out there. Snap. Is it a different picture?
Yes.
Yes, that's helpful, isn't it?
Yes.
You got that picture of the shortest to the tallest, and all of a sudden you mess it up. Position matters. Okay, this is a permutation. No. What do we got here? Parentheses what? Only one person's in the photo?
No, 12.
Got him. It says 12 people lined up in a photo. You got tricked by my one row, didn't you? Come on, you got to visualize the situation. Think about it. You switch 2 people, then you switch 2 more people, then you switch 4 people, then you switch 6, then you... Yeah, it's going to be big. Let's see if I remember it from memory. 0, 0, 1. Is that right? I just calculated that in my head. No. I did not. I remembered it from first period. Permutation, the position matters. In a permutation, the position matters. All right, go down to where it says careful. In these problems with multiple groups, just multiply the number of items in each group to find the total number of possible combinations. The classic example here is, man, we're all going down to Applebee's. On me. You can get an appetizer, an entree, and a dessert. They got 3 apps, they got 5 entrees, they got 2 desserts. Pick one of each. Is there enough different combinations for everyone to eat a different meal?
Yes.
Okay, well, maybe, maybe not. Okay?
You taking me how to class?
Maybe, maybe not. If everybody makes advanced, yeah. But I will take care of all the people that make proficient in advanced. I'm not gonna take you to Applebee's. Come on now.
You can work after these too. Yeah, we can go to CC.
6 drinks, 5 sandwiches, 4 bags. You got to pick one of each. This is a dead giveaway that it's a multiple group. If it says one of each, look how else it could say one of each. The next problem says 1 app, 1 entree, 1 side, 1. It's still saying one of each. This one says 1 consonant, 1 vowel. This one says 1 of 8, 1 of 10. This one says, look at this one. This one says A. If it says one of each in one way or another, you pretty much guarantee that it's a multiple group. Okay, and all you have to do on these, I won't insult your intelligence, I'm almost done with this. 4 times 5 times 8. Sorry, let's go back up to the one we were actually doing. Come on, coach, what are you doing? 6 drinks, 5 sandwiches, 4 bags. So 6 times 5 times 4. Don't use your calculator, you can do that in your head. 6 times 5 is 30 times 4. You know what 3 times 4 is.
How we doing for these? One time.
No.
We'll do one more together. How about number 10? No, my favorite one is number 9. How many 2-letter pairs of a vowel and 1 consonant can you make from the English alphabet? Consider Y not to be a vowel, but to be a consonant. Y'all do not read carefully. Y'all do. Thank you. It says one of each. A B, A C, A D, A F, A G. Mixed review, you gotta be careful. Okay, mixed review, you got to pick the right one. Is it a multiple group? Is it a permutation? Is it a combination? All right, on the back is more practice. Questions at this time? I think my space bar, you know, sometimes it just doesn't work. Yeah, sorry about that. The Aaron's going to have to for her in the family. All right, cool. I'm going to let you get working.